All right, the homework for Unit 7, Section 1, Day 4, I'm going to skip around again. A lot of these are very repetitive, especially since you're just putting these in the calculator. You just need to figure out your lower, your upper, your mean, and your standard deviation. And we can do this first one here. So find the probability that our x is less than 5. Okay, so what are we talking about here? We got 1 gallon cans of dusty rose paint. Sure. The mean is 5 milliliters. The standard deviation is 0.2 milliliters. And find the probability that we get a can that is less than or equal to 5 milliliters. All right, so we need to know our lower, we need to know our upper, we need to know our mean, and we need to know our standard deviation. The mean and the standard deviation should be given to us. If it's less than or equal to 5, 5 is going to be our upper bound, and I believe the lowest amount of paint you could have in a can would be 0. So 0 is sort of our natural lower bound. But again, as long as you go, a decently low number with that, like relative to a mean of 5 and a standard deviation of 0.2, you should be good. Put that in your calculator. See what you get. So do your normal CDF. I'll do just this first one. This will be the only one I sort of spell out. But if we do normal CDF here, we get second vars, second option, and then you should see a screen that has lower, upper, mean, standard deviation. I have the older calculator. So I'm going to 0, 5, 5.2. I'm going to hit enter. I'm going to get 0.500, so basically just 0.5 or 50%. So that's A. If it's, I'm going to skip over B. It's the same thing. Let's do C. So between 4.6 and 5.2, so these are nice and easy. The lower has to be 4.6, the higher is going to be 5.2. Our mean is 5, our standard deviation is 0.2. Go put it in the calculator. You should get around 81.86%. And then let's do one of these over here. I'll do D. Value greater than 4.5. So our mean is still 5, our standard deviation is 0.2. If it's greater than 4.5, 4.5 is your, is your lower. And your upper just needs to be a pretty large number. Now, if your mean is 5 and your standard deviation is 0.2, 10 is probably going to be fine here because it's going to take a lot of standard deviations to get up to 10. And really, if you just go 3 standard deviations up, that should contain most of your data. But you could probably just say 10 here if you want to say 100, 1,000, a million. It doesn't matter. Just make sure you're going up a good amount relative to your mean and your standard deviation. If you're really confused at what I mean by relative, then always put a million and you're probably going to be fine. I'm just going to use 10 and put that in the calculator. You should get somewhere around 99.38% of your data. If you're a little different from me because you used 100, that's okay. If you're like at 99.37 or 99.36, or 99.39, it's fine. All right, let's flip over. So finally, we have some word problems here. I should have gone in and crossed out quite a few of these for the parts of the notes that we did not do, but they're not crossed out on this first initial one. So like I know I took out C on y'all's homework. So just A and B here. Consider babies born. Extensive data support the assumption that such babies born in the United States have a birth weight that is normally distributed with a mean of 32 grams and a standard deviation of 482 grams. What is the percent of babies whose weight would exceed 4,000? All right, so we need a lower, we need an upper. We need a mean, we need a standard deviation. The mean and standard deviation is given to us. If it's exceeding 4,000 pounds, that means 4,000s are lower, and upper needs to be a pretty large number. And again, all right, so obviously 100 would not work here for this. 1,000 is probably too small as well, considering our mean is 3432 and our standard deviation is 482. So I'm just going to be safe and pick a million here. And I'm going to put this in the calculator. I'm going to see what I'm going to get. You should get 11.93%. On B, you're finding the percent between these two numbers, so that's nice. The lower is 3,000, the upper is 4,000, the mean's 3432, and the standard deviation is 482. Put that in the calculator, see what you get. It should be about 69.56%. On number 3, you know, it's the same deal. I don't know how much I want to do here, but what percent of randomly selected tanks will hold at most 14.8 gallons? So if it says at most, that's less than 14.8. So if we're doing lower, upper, mean, standard deviation, at most 14.8, so that's our upper bound. 0 would be our lower. We're talking about gas in a can. You can't have less than 0 gallons of gas. Our mean was 15, and our standard deviation was 0.1. You just want to put that in the calculator, see what you get. You get 2.28%. If you're doing 14.7 to 15.1, these are the nice easy ones. Lower, upper, mean, standard deviation. Lower would be 14.7, upper would be 15.1. Mean is still 15, standard deviation is 0.1. Should get somewhere around 84%. I took out number 4 for y'all. I took out 5B through 5C. And yeah, I'm going to leave y'all to do number 5. I'll have it filled out for y'all on the actual answers, but yeah. All right. If you have any questions, please email me. I think this was a lot easier than the day 3 homework. Take care.